Today we are going to do section 6.2, which is going to be a somewhat short section. Okay, we're mostly going to talk about the graph of the exponential function. Now please look at the bottom page 561 where we have this chart, right? And that we have seen in the previous section, where if you want to plot, say, 2 to the power x, right, you have a bunch of points, and then which give you a pack of numbers. As you can see, as x becomes negative, f of x becomes closer and closer to 0, but it stays positive because you are using 2 raised to the power of a negative number, which becomes a fraction. Now, if x is positive, on the other hand, then the value of f of x will increase rapidly. Okay, because your raising is exponential, right? So then if we were to graph this thing on the following page, okay, now it will look something like this, as we have seen in the previous section. Now in this section, I want to emphasize, we're emphasizing on the graph itself. So I want you to graph this thing as part of your homework. This is what? This is the page 562. Please graph this in the Desmos graphics calculator. If you don't have it, maybe then perhaps graph it by hand. Either way, please graph this thing in preferably in the calculator. Okay, and I want to make sure that everybody knows exactly how to do this. So I typed out some instructions, very detailed instructions on how to type stuff into the Desmos calculator. Now, if you are familiar with typing stuff into calculators, then this probably doesn't matter to you, okay? Which is, you can just skip this part. So here is what I want to show you. These are the exact instructions on how to type into the Desmos calculator. For example, to type in y equal to 2 to the power x plus 3, you type in y equal, okay, I have the buttons typed out exactly here. And to push to raise the power, you push shift 6. Generally, if I have 2 buttons here, that means you push shift together. And in this case, you should type in the parentheses. And Desmos might be able to do it even without parentheses, I'm not sure, but it's safer to type in parentheses if you need to type in, this is 1/2 to the power x, okay, either one. So please take a screenshot if you need this information, and to make sure that you know how to type stuff into Desmos. Now anyway, so I typed that graph that I told you to type into Desmos. Okay, here is what I have. Right. So I typed in there are several lines here. I think the blue line is y equal to 2 to the power x. That's what we're doing right now. See this thing right here? And corresponding blue line, okay? And then, so please do this yourself. This is just a screenshot from Desmos that I typed in. And I also type in the other two. One is +3 and one is -3, and see what happens. +3 means the whole graph got lifted up 3 units, and -3 means it got descended 3 units vertically. Okay, so you take the graph, you don't move it sideways at all. You just either move it up 3 units or straight down 3 units, and that's what it looks like. Okay, so please type it in yourself, and you can play with it and have it plus more, say 10 or -10 or whatever, and see where it goes. And so that's what's so great about the Desmos calculator. And that is right. And then the next thing I want to talk about is I need to get out of here. And what am I doing? Oh yeah, textbook. Okay, I got the book back. So we have, and so the next thing is, what if the function, the first one we typed in is 2 to the power x, right? Now, what if we want to do, instead of 2, we want to do 1/2 to the power x, right here, 3 to the 1/2 to the power x. You can plot out the points, right, and figure out what each value is. 1/2 to the power -3 is actually 8, because to the negative power is the same as 1/, okay, like this. And you see, when we have 1/2 to the power -3, what is 1/2? Well, 1/2 is the same as to the power -1. This is from chapter 1, okay? And then, and to the power -3, and these powers multiplied together, that's again from chapter 1. So this is the same as 2 to the power 3rd which is equal to 8. That's why this thing suddenly got turned into 8 for some mysterious reason. If you can't remember how the exponents work like this, please review chapter 1, okay? I always say please review chapter 1 whenever you feel like it's a little bit slipping away, because it's used all the time like this. So then if you do the same thing here, okay, and then we have all the stuff, right? If you do the same thing, then eventually you have the entire graph. You notice that it basically is the reverse of this situation. That is, the negative side now is big, whereas the positive side is going to 0. And so when you graph it, then it looks like you would expect. See, basically, it's the same graph, except that it got flipped around. So please graph this yourself as well, okay, as well as the previous graph. And then that is the, yeah. All right, so the two graphs, as you can see, they have a similar looks symmetrical. They just got flipped over. This is when b, the base, is bigger than 1, okay, then it increases, whereas when b is less than 1 but still bigger than 0, b has to be positive, okay? So when the other way, it just flipped around, it's called decaying, okay? It just passed out and got closer and closer to 0, but it doesn't go past the x-axis. That is, doesn't become negative or anything. It just dives down and then it kind of rotted. So that's the decaying graph. So let's look at the next page. Let's see, didn't I have, give me a second here, what am I missing? Oh, maybe that happened somewhere else. Okay, never mind then. So let's look at graph example 1. So example 1, you're supposed to sketch a graph of f of x equal to 0.25 to the power x. This is on page 564. Now we have just mentioned that when the base is less than 0, in this case the base is 0.25, which is less than 0, then it is a decaying graph. So this graph look like, oh, it looks something like this, okay? Yeah, exponential graphs always look like either this or the growth one. The decay one or the growth one. This one happens to be the decay one. Please plot this into the calculator, and then you know everything about it. Instead of this, your book wants you to do it by hand. Let's not. You know, we are not paid enough to do that much work, and we have the calculator. Let's use it. So just type this into the calculator. The y equal to 0.25 to the power x. And then that should spit this thing out beautifully for you right away. That's example 1. So please do that yourself. Oh, here it is. Here's the shifting that I was looking at earlier. What is that? This is page 565. Now I want you to plot this page into the Desmos calculator yourself as well. It's rather simple to do, because what you do is you type in one of them, right? Where is it? Yeah, the f of x equal to 2 to the power x. Then you just copy and paste. You don't type in f of x. You just type in y or something, or not even that. You can just type in 2x. And you'll plot the graph. So anyway, once you type it in, you just copy and paste it into a new line, and then you have, and then put a -3 there, so that the next graph is 2x minus 3. And then the 2x plus 3, which one's plus and which one? Yeah, the top one's plus. Okay, when it's plus 3, it moves up, and the -3, it moves down. And let me show you what I have, that's what I have before as well. Let's see, where's the graph? Yeah, this is it. Okay, so here we are. Come on, get bigger. Nope. All right, it's bigger. All right, so in Desmos, you can, here's the first line. You can click in the second line where there's an open space, and it'll let you type in the second graph. This is too big. Okay, and then you click down here and type in a third graph. See, Desmos let you type more than one graph on the same page. And the way I typed it in, I just should put y equals to f of x, which is fine. You don't have to type in f of x. Y is good now. So once you type C, I typed in 3 things, and then it's color-coded right? And also remember in decimals, you can click this. This is a button. If you click it, it will disappear. And then click it again, it will turn back on. So if you don't want to see a graph, then you can just click it and make it disappear, okay, instead of deleting it. And similarly, these. And then notice that they're color-coded. So the green one is the bottom graph, okay, the -3 and so on. So please do this yourself as well. And similarly, the 1/2 power is the same way. If you want the decaying graphs, okay, they look just like the other one, except that you have a fraction in the base. So the base is once it's base is less than 1, you have a decaying graph, and you just type it in. See, there is the middle one, and +3 and -3. So that is the two kind of graphs. That is, see, normally when you add things to a graph, then you lift the graph up, okay, by a constant, or if you subtract, then you push it down by the same constant. All right, so that is that. And now let's go back to my textbook. I suppose I should mention that when things are being lifted like this, then the asymptotes also correspondingly move. That is, the middle graph is f of x equal to 2 to the power x, right? But if you lift it, it has an asymptote. The horizontal asymptote is x-axis. When you lift it up 3 units, then the new asymptote will be y equal to 3, okay? And push it down, then the new asymptote becomes y equal to -3, and so on. And similarly for for this one, let's see, this one got pushed. This one is shifting differently. What happens is with the bottom graph picture here, we're now on page, let me see, what page are we on? 566, okay. Actually, 565. See the bottom graph, you are not moving stuff up and down, you're actually subtracting numbers in x itself, see? I mean, if you can, look at your book on that page, see, you have 2 to the power x, and then x itself is being subtracted by 3. I don't know if you can see that clear enough. Yeah, and then g is being +3. So as a result, when the increase is in x instead of y, then the shift is going left or right. It depends on in the plus case is moving to the left, and the minus case is moving to the right, as this graph shows. And you can type it. Please type this into the decimals calculator. Okay, enter these graphs, and then it will show you very nicely. All right, and in just a few seconds. See, it looks perfectly good. But notice the asymptote doesn't change because your base, So then it's just the graph simply got moved around a bit. All right, so that is that. Okay, so next let's look at example 2 on the following page, where you're supposed to graph the f of x equal to some exponential function. It wants to know the domain. Well, the domain for most for exponential functions normally is everything, okay, from -infinity to infinity. The exponential function doesn't have a problem with domain. The range is usually from positive y to infinity. It doesn't, because the exponential function doesn't drop down past its asymptote. Okay, depends on where the asymptote is. In this case, it's on the x-axis, but if you had lifted up, like I showed a little earlier, then the range will be somewhat higher. Or if you dropped it down, it's somewhat lower, and so on. So then, but the range and domain is, it's just something that you sort of pay some attention to. And the asymptote is wherever this thing dies at. Okay, where's it dying? Right now it's dying at the x-axis, so that's its asymptote. So please type this in this function 2x plus 1 minus 3 into the decimals calculator, and that should give you this thing right here. Now, if you type something into the calculator and it doesn't look like this, then you better make sure that you didn't, either the book is wrong or you are wrong. You are probably wrong though. And let me, this is x plus, well, anyway, wrong in the sense of you typed in the wrong thing. You know, maybe you typed in +3 instead of -3. It wants -3 here, that sort of thing. So, but it should look identical to what the the book has. Although it is true, however, that the book's scale is different. See, the decimals, you see the book from left and right only goes from about -5 to 5, but from top to bottom as about the same distance is going from -10 to 10. In other words, the book changed the range of the y-axis. Otherwise, the thing just looks really skinny and crawl up, and you can't see what it does. So in that sense, if you don't change that value, then your graph might look a little more steeper than what the book shows. But it should be basically the same. And you can tell that it is the same by calculating the y asymptote, okay, when x is 0, and then y had better be -1, that sort of thing. And then and those things will confirm whether your graph is correct or not. Anyway, that's example 2. Let's move on to example 3 on the following page, which we're going to skip, okay? It has you use a calculator to solve the exponential equation. That is, we're not going to do that right now. It's a waste of time. So let's move on to example 4, where we're stretching things. Okay, now we have learned how to stretch functions. To stretch a function, you multiply it by some constant. Or put it another way, and then to shrink it, you multiply it by a fraction, okay? A fraction constant, whereas to stretch it, you multiply it by a big number. Like, for example, let's look at example 4. Example 4 is the same function, except it got stretched. So what happens is the graph got a lot, longer. So the way, go ahead and plot this into the graphics calculator, and you will see what I mean. Especially plot both this function and the original function that is without the 4 in it, and you can compare the two. As you can see, again, that this graph, the one that the book plotted, doesn't look very stretched. The reason is because they adjusted the y value, so the y goes up to 10 when x only goes to about 5. So the stretch function got squashed in the view, and so that you can see it better is the only reason. Otherwise, it doesn't fit into the screen. That's that. And then next, let's look at example 5, where we have what is that? Okay, we need to reflect something. Okay, the reflecting principle is the same as we have learned in the past. That is, in how to reflect a function in general. Let's see. Let's look at the top of page 569. Now, on top of page 569, we have various things you can manipulate the graph to see what it looks like. The best way is for you to just type in these things into the decimals calculator, and then and see what it looks like. For example, when you have f of x if you have 2 to the minus x, so here's the original 2 to the x, what does minus x look like? Minus x looks here. Basically, you got a mirror image where the mirror is the y-axis. Okay, you just flipped it around this way. And then this one is if you slap a negative sign in front of it, okay, g of x is -2x. In that case, then what's up is now down. It's the mirror image with the mirror being the x-axis, okay? So that is, that's all there is to it. And so please type these things into the decimals calculator, and then you can stare at it a little bit. And that should be good enough. And next, let's look at example 5. They want you to reflect something. The function is reflected across the x-axis, right? About the x-axis. Now, as we just mentioned, to reflect about the x-axis, you just slap a negative sign on it. See, right here. This graph even says so. You just slap a negative sign on it, then you're good to go. So then that's what we're gonna do here. Slap it. See, that's even what the book says. We're slapping the negative sign on there, and now your function is reflected. That's all. Okay, so please do that yourself, and then we'll move on to the next page. Next page is not that. Well, there's also a concern of domain and range. That doesn't change much. It depends on the reflection. Your domain maybe used to be positive since you reflected it down, and then the range is negative. The domain doesn't change, but the range becomes negative. It's that sort of thing. So next, Next part is what if we do a bunch of stuff, okay? We're going to stretch it, shift it, reflect it, and so on. So, well, then you just do each step. Or just type the whole thing into the calculator and call it done. Well, let's look at example 6. Yeah, go ahead and do example 6. Well, we have f of x, e to the power x is stretched by the factor of 2. Okay, so you multiply by 2, is reflected across the y-axis. That becomes, I'll just write it down. Okay, this is example 6. So in example 6, we have y equal to e to the x, that's the beginner. Y equals to f of x, you can call it either one. So y equal to e to the x is vertically stretched by a factor of 2. So the next step, y will be now 2e to the x. It says stretched by 2, fine. And then reflected across the y-axis. Now to reflect things across the y-axis, it says that to do that, you slap a negative sign on x. Okay, it says right here. See, to reflect it, slap negative sign on x. So let's, do that. So the next step, the new function is y 2e to the power minus x. And then the next thing, what they want is, and then shift up 4 units. So then we just add 4. That should do it, okay? And that's everything is said, yeah? And that is the right answer. All right, so that is the end of this section. For homework, please simply redo all the examples that we've done, especially type stuff into the Desmos calculator. Make sure you know how to type things in there. And other than that, there is no homework. Okay, I feel that this is if you do that, that's frankly more than enough. So so that will be all we're gonna do for this section.